Let's take a look at number 4. It says find the volume of the solid of revolution formed by revolving a region bounded by y is equal to x minus x squared and the x-axis about the y-axis using the shell method. Now this is the formula we're going to be using. The shell method about the y-axis, graph bordering the x-axis. Let's look at the graph just to confirm that. So we got y equals x minus x squared. So let's graph this. I'm going to press my y equals, press clear. X minus x squared, yep. So x minus x squared. And I'll do a zoom and I'll choose 6 for Z standard, set it back to standard viewing. Now I can't really see this very well, but that's okay. If I press zoom and I choose zoom in, the second one, and then press enter, and then once it comes up here, press enter one time, I see that region bounded by that and the x-axis, about the y-axis. So it's bounded by the x-axis, so it looks like it's from 0 to 1. But let's confirm those upper and lower limits. So we'll find our points of intersection. So POIs. Now the x-axis is y is equal to 0. So whenever they say the x-axis, that's what they're referring to. So we're going to set the x minus x squared is equal to 0, and then go with this. Well, I can factor out a GCF of x here, which will give me 1 minus x. Now set each factor equal to 0, so I set x equal to 0, and 1 minus x is equal to 0. And this one, take the negative x to the right side, becomes a positive x, so we get 0 and 1. That's no surprise, that's what it look like. Now our formula is over here. We want our volume is equal to 2 pi, and a to b we just found it was from 0 to 1, and then this is always x for this particular type, times, and then our h of x is going to be x minus x squared, and then dx. Now that's because of how this picture is arranged here. If we had a different setup, it might be different values there. But again, this is very, very straightforward. So multiply this x through, and I got x squared minus x to the third dx. Well, then we're going to add 1 to our power, divide by our new power. So we got 1/3 x to the third minus, add 1 to our power, divide by our new power, 1/4 x to the fourth, 1 to 0. And if I plug in those values, plug in a 1 first, I got 1/3 times 1 to the third power minus 1/4 times 1 to the fourth minus 1/3 0 to the third minus 1/4 0 to the fourth. Now those zeros are going to all drop away, so we don't need to worry about those. 1 to any power is 1, so we don't need to worry about that. So we got 1/3 minus 1/4. And we want to get a common denominator, which would be 12. So multiply this by 4, top part by 4. Multiply this by 3, multiply the top part by 3. So that gives us 2 pi times 1/12, which gives us 2 pi over 12, which gives us pi over 6 is our answer. Assuming I didn't make a basic math error somewhere in there.